Greetings and welcome, ladies and gentlemen. We're starting a new zone, a new topic, a new chapter, if you will. We're talking about polynomial, polynomial, and radical expressions in this chapter. We'll actually be in this chapter for quite some time, just so you know. So our first chapter was just kind of like a quick little introductory zone. Started off nice and, with familiar territory, hopefully, and we're able to get some of those basic skills reminded back into our brains, if that's a way I can use the word reminded. But today we're starting a new zone and a new topic as a result. So polynomials relate to monomials. I don't know if you could tell. The mile is the similar thing there. And we'll talk a little bit about those today. But so monomial is I guess I could define a monomial for you. A monomial is a single-termed expression. Okay, so that's what a monomial is. And I guess I should tell you what a term is. A term is composed of a variable or variables, exponents, and a coefficient. Okay, so what I mean by terms is stuff like this. For instance, I guess I'll write in my secondary color. A term would be like 3 is a term. All right, I could have a term like this, like negative 5x squared is a term, right? It's got a variable, it's got an exponent and a coefficient. Coefficient is the number being multiplied by your variable. You could also have something like this, 2/3 x squared y to the 5th, right? So I could have multiple variables, plurality of them even. And this is still a single term. So within a term, the only kind of operations I have going on, I guess, between my variables or stuff is multiplication. All right, I don't have addition going on. Once I have like 2x plus 1, this would not be a monomial. This is in fact binomial because it has two terms. Here's one term and here's another term. So terms are often in expressions separated by plus or minus signs. Okay, so this is not a term, not a monomial, because it has two terms. All right. So there's some of that. But before we do any more of that, I actually want to talk about some properties of exponents, and I'm hopefully going to cover a handful of them today. So the first thing I want you to do is consider the following. Okay? Let's say I've got 2 times 2 times 2. All right? What's another way I can write that? Does anyone remember? 2 to the third, or 2 cubed is the kind of vernacular that you might use to describe a third power. So there were 3 2's going on there, right? So there were 3 of them, and they were all the same number. So that's why this 3 and this 3 are buddies, right? And the 2 here is related to that as well. So just some things to look at. The 2 itself, all right, is called the base. The 3 is called the exponent. And the whole thing, I guess that I'll do that in a different color. The whole thing is called a power. All right. So just some language there for us. Now, what if I had this? What if I have 2 times 2? What if I had 2 squared times 2 cubed? 2 to the 5th. So I have a possible solution here, but let's verify that. What does 2 squared mean? 2 times 2, right? And I'm multiplying that by 2 cubed, which is 2 times 2 times 2. So that's a total of how many 2's? 5 2's, right? 5, right? And 5 happens to be these 2 plus these 3, right? So it appears as though my way of simplifying this would be that's the same as 2 to the 2 plus 3 all in the exponent, or 2 to the 5th, which is you correctly described and ascertained, right? So 2 to the 5th is a simplified way of writing that. If I wanted to evaluate that, I could multiply 2 by itself a total of 5 times, or 5 factors of 2 is probably the more accurate way to say that. And 2 to the 5th is 32, if you're wondering. 2 squared is 4, 2 to the 3rd is 8, 4 times 8 is also 32. So a bunch of different ways you can think about that. So that's our first property I want to talk about. So here's our first property. This is the product of powers property. Product of powers. Here we go. Oh no, man, now I'm singing while this video is recording. That's embarrassing. So product of powers says that a to the m times, a to the n is equal to a to the m plus n. Okay? So the stipulation here, man, the squirrels are excited over there. The stipulation here is that I'm multiplying two things that are the same, what? What was the word that? Base. The same base. So if I multiply two things with the same base, I can add their exponents. All right? Agreed? All right, let's consider some other facts. Well, let's actually do a quick example of this, maybe. Why not? Why not? So what if I've got 2 times x to the 3rd y squared multiplied by 2 to the 4th x to the 1st y to the 5th. And I want to multiply these things. All right, we're just jumping right into the mess here. Now, I don't know if you guys realize this, but what is the exponent on this x here?
1.
Yeah, there's actually a little invisible 1 hiding right there, like a hobbit wearing a ring. Right? He was just like invisible. And he's even tiny like a hobbit, right? He's a little one, right? He was sneaking there. And what about this 2? Does this 2 have an exponent? Oh, bingo, Waldo, look at that. Loop-de-2 and not a 2. What? Z2, loop-de-2. 2 Z's, right? So what is the exponent on this? Technically, there's also a little 1 there, right? Like a hobbit wearing a ring. So what I can do here, this is going to be the same as 2 to the 1st plus, let's see, when I multiply 2 to the 1st times 2 to the 4th, that's 2 to the 1st plus 4, right? Normally, we won't have to write out this step. I believe you can do the addition in your head. X to the 3rd times x to the 1st is the same as x to the 3 plus 1. And y to the 2nd times y to the 5th would be the same as y to the 2 plus 5, right? So this simplifies to being 2 to the 5th, x to the 4th, y to the 7th. Is this a monomial?
No. Yes. Yes.
Yes, because this is only multiplication going on between those, all right? If there was a plus sign or a minus sign between that, no, that would be one term and this would be another. Okay, so just be aware of some of that language. All right, let's consider another thing. Consider. All right, I see where how we're doing this. What if I wanted to figure out what is 2 to the 3rd squared? Well, let's see. What does 2 to the 3rd mean? 2 times 2 times 2, right? And what does squaring something mean? Multiplying it by itself, right? So that's the same as 2 times 2 times 2 times another 2 times 2 times 2, right? That's a lot of 2's I just wrote. And no loop-de-2's at that. So how many 2's are there? 6. So 2 to the 6th is a way I could write that. 2 to the 6th is 64, if you're wondering. And does anyone see a shortcut how I could have gotten to this 6? Yeah, 3 times 2 is 6, right? Look at even here. Here's 2 sets of these 3 2's, right? Here's, right, 3 2's here, 3 2's here, and there was 2 sets of that. The 2 times 3 is 6, right? Whichever way you want to think about it. So this is called the power of a power property. Hopefully you've seen some of these before. Hopefully they're familiar to you guys. So power to a power property says that a to the m all to the n is equal to what?
Marker. Highlight.
So a to the m times n is what that would end up being. All right, so that's what our new property is. Does that make sense? So one of the things you guys will have to be careful of is remembering when you add exponents and when you multiply them. All right, that's going to be kind of the thing that you'd have to determine. Let's see, I'm going to jump right into another consider here. What if I had this? What if I have 2 times 3 all squared?
I'm going to do this to the staff today, show them what we're up against.
Okay.
That's a good idea, right?
Yep.
I'm going to add Green Mountain Star in here somewhere. I don't know.
All right.
So but these are the ones you need to have ready for me.
Okay.
Would it be 2 squared times 3 squared?
Yeah. Well, let's see. What does it mean to square something? It means to multiply this by itself, right? 2 times 3 times another 2 times 3. Or, hey, these 2's could pair up and those 3's could pair up. That's the same as 2 squared times 3 squared, right? So how would you describe what we just did? Yeah, perfect word. I would describe that as distribution, right? Just like how multiplication can be distributed over addition or subtraction, it turns out exponentiation can be distributed over multiplication. All right? So that's a distributive property. You could, we'll call this power of powers property. And what I would have here is that actually I'll even write it this way, a to the m times b to the n all to the p. Whew. Lots of letters floating around there. But it's going to be a type of distribution. Let's see, what do you think is going to happen between the m and the p there? Do I multiply or add? Multiply, because it's a power raised to a power. So that would be a to the mp times b to the np, right? There's another property under our belts. We just got it. Bam. Right? So, let's see how far we got here. All right, let's do one more. Let's consider. Yeah, we get out at third. No, you guys are right. Okay, 10:28. My apologies. This video's over. Bye, internet friends.